Welcome to our final lecture on causation. This is David Lewis, and he's going to offer us a counterfactual account of causation. Lewis finds the roots of his account in Hume. We thought of Hume as a regularity theorist, right? And certainly some of what he says definitely sounds like regularity theory. But Hume has also offered another account of causation, or what seemed like a definition of causation, that goes like this. If the first object had not been, the second had never existed. So the regularity version of Hume's account has been worked out in great detail. We've gone through, right, Hume to Mill to Mackey, and it still has problems. Maybe those problems can be worked out. But Lewis says, let's look at that other definition and see if maybe it's time to explore that account of causation. So again, Hume's definition is a cause is an event that if it hadn't happened, the effect wouldn't have happened, right? So it's a counterfactual, right? So I did drop my phone, it did hit the ground, right? But well, if I hadn't dropped my phone, it wouldn't have hit the ground. Therefore, my dropping of the phone is the cause of its hitting the ground. So this avenue, right, these sort of suggested passages in Hume hadn't really been developed before Lewis's writing in like the 70s or 80s, because there hadn't really been a satisfactory analysis of counterfactuals. So a counterfactual, again, is something that hasn't happened but could happen, right? So it's hard to say what makes a counterfactual true because it's something that didn't happen, right? So, if I say if I hadn't struck the match, it wouldn't have lit. You want to say, yeah, that's true, but what makes it true? Especially if in this world I did strike the match, right? If we've been sort of implicitly using what we call a correspondence theory of truth, right? A sentence is true if it picks out some state of the affairs in the world accurately, right? But counterfactuals are about the way the world could be, not the way the world is. So they're specifically about stuff that didn't happen and what makes those true, right? If there's nothing in the world that makes it true. There are, various accounts of counterfactuals, and we're going to see for the rest of this course basically a lot about Lewis's account, which is a possible world semantics, and it's what we call a modal realism, right? Where he thinks the possible worlds actually exist. That's not the only way you could cash it out. That's the way he does it. He thinks it's overall the best approach. So, according to Lewis, what makes it true that if I hadn't struck the match, right, it wouldn't have caught on fire, is that there is a possible world where I didn't strike the match and it didn't catch on fire, right? Now there's going to be lots of different possible worlds, right? There's even potentially a possible world where I didn't strike the match and it still caught on fire, right? Maybe someone else lit it or something else happened. So we also have to talk about a nearness relation, right? And the counterfactual is going to be true just in case the nearest possible world is one where I didn't strike the match and it didn't light on fire. We'll get more into the details of what that nearness relation could mean. But for now, that's just introducing. Okay, so before Lewis sort of lays out his counterfactual account of causation, he says that in order to make this manageable, I have to sort of like draw a few lines about stuff I'm not really going to deal with. Right? So he says, I'm only going to talk about causation among events, so not among objects. So if we think that something, right, that a billiard ball can cause another billiard ball to move, he says, I'm not going to talk about that. I will talk about the event of a billiard ball striking another billiard ball, right? Hopefully that's intuitive, the difference between an event and an object. An event is a thing in time, right? He's going to talk about, number two, just individual causation. So individual causes and effects. He's not going to talk about causal generalizations. Now, we saw that's an important problem that needs to be solved in the last lecture, and we saw that it was a problem for Mackey. But he thinks that we're not really even yet on, we're not precise enough about what we mean by causal generalizations to even be ready to do a good account, right? So a lot more needs to be said. Like when we say all C's cause E's, do we mean every member of C causes a member of E? Right? Do we mean that for every member of E, there is a member of C that is its cause? These are distinct claims. Is it another claim? Someone needs to make that precise, and he doesn't have the time to do it in this article. 3, he's not going to solve the problem of whether every event has a single cause or some set of causal factors. He says, I'm just going to work out in the most general sense what we mean by cause. Right? So each of those possibilities is a little bit more specific, right, than he can get right now. And finally, he's going to assume that determinism is true, right? Well, determinism means that the laws of nature, right, dictate a single outcome, right? It's the claim that the universe is not sort of probabilistic, right? So if we knew all the initial conditions, right, all the forces, all the laws, and how every atom was set up, we'd be able to predict every next thing. Right? It's not no chance involved, right? So if you know anything about quantum mechanics, that's probably not true. There are some areas of the world, some parts of the world that are probabilistic, but for simplicity, for now, he's going to be talking about deterministic causation, which seems more or less true in the world of, everyday medium-sized objects. Okay, so to get any further, we need to flesh out Lewis's account of counterfactuals a little bit. And to do that, we need to talk about possible worlds. So if I say, if I had married Alice, everything would have been all right. According to Lewis, that means there is a possible world where I married Alice, and everything is all right. But since there are so many possible worlds, there is also a possible world where I married Alice and everything is not all right, right? So what makes the counterfactual true? Well, if it's the nearest possible world, right, is the one where I married Alice and everything turned out all right. So how do we flesh that out more precisely? Well, we need to talk about similarity, nearness, right? And a world that is more similar to ours is nearer to ours, right? And any possible world will have some similarities and some differences, right? So you kind of have to add them all up, and they kind of have to be weighted, right? So some differences are more important than other differences. And once you've added them all up, the more similarities, right, the higher similarity score, the closer it is to our world. So, for example, if world P is just like the actual world, everything is the same except that I'm a carpenter instead of a philosopher, and my hair is black instead of blonde. Well, that's going to be further away than a possible world where I am a philosopher and my hair is black. So there's 2 differences in the one world and only 1 difference in the other world, so that world is nearer to ours, right? Now, obviously, this could get very messy. Like, what other facts would change if my hair were black, right? And what differences are more important than others, right? What's a bigger difference, my hair being black or me being a carpenter instead of a philosopher, right? If we had 2 worlds where only one of them has changed, which one is nearer? Lewis says, look, yeah, there's going to be vagueness here in this similarity relation, but that doesn't mean we can get rid of it, right? That we should get rid of it. Vagueness exists in the world sometimes, right? Is somebody bald or not? Sometimes there's no clear answer to that, right? And there's vagueness in causal claims often, and so a little vagueness is not going to kill us. One important distinction to point out, right, is that you can have similarity and difference in individual facts, right, the color of my hair or my occupation. You could also have similarity and difference in laws of nature. So there could be possible worlds where the laws of nature change. There could be a possible world where the gravitational constant is different. Well, that's going to be, Lewis thinks, a bigger difference. Like, laws of nature count for a lot, right? So a changed law of nature, that's weighted much, much more than a change in my hair color, right? If a change in any individual. Usually, if there's a changed law of nature, that world's going to be pretty far away from ours. Okay, so now he's going to talk about truth conditions for counterfactuals, right? So this was the problem that kept people from pursuing Hume's other definition, is there wasn't a great account of what makes a counterfactual true. Here's Lewis, he's going to do it. And he uses this sort of notation. This is not super standard to me, like it just appears in his paper. I haven't seen it in a lot of other places, but this is what it looks like. So here's a counterfactual, A, box, and C, right? Which for him means if A were true, then C would also be true. Okay, this counterfactual will be true just in case there are no possible A worlds. So, right, if the antecedent is false, then the whole conditional is going to be true. That's just a thing of logic, right? It's vacuously true, not the interesting case. Our interesting case is it's going to be true if there is an A world where C holds, right? that is closer to the actual world, which we'll call W, than any A world where C does not hold, right? So if I had married Sally, then everything would be okay, right? So that means that there is a world where I married Sally, where everything is okay, and that world is closer to our world than any other world where I married Sally and things are not okay, right? So if the nearest world is one where I married Sally and everything's okay, then the counterfactual, if I had married Sally, everything would be okay, is true. Right? In other words, it takes a larger departure from reality to find a world where C doesn't hold than to find one where C does hold. That's what makes the counterfactual true. Okay, so given this definition of counterfactuals, truth of counterfactuals, now we are going to start to define causation, but he has to define a few intermediate relations first before he gets to causation. So he starts with something he calls causal dependence that is different from causation, right? So causal dependence is defined in terms of classes of events that tend to depend counterfactually on each other. So take a set of propositions. Sorry, I got called away by a toddler. Her stuffed cat in the baby jam issue. Okay, so back to causal dependence. So take a set of propositions, none of which are compossible. So A1, they're A2. So if they're not compossible, it means they can't be true at the same time, right? And then take another similar set, call it C. So if all of these counterfactuals were like, if A happened, then C happened, 1, if A2 happened, then C2 happened, and all these different counterfactuals, if those are true, we'll say that C's depend counterfactually on A's, right? So what does that mean? That's a little abstract. For an example, let's say levels of barometric pressure and barometer readings. So the A's are, right, atmospheric pressure, and C is the barometer reading. So all the different possible barometric pressures are not compossible, meaning the barometric pressure is either going to be 29 or 30 or whatever, right? It's not going to be both 29 and 30, right? The A's are not compossible. Same with barometer readings, right? So the barometer is going to display one number. It's not going to display 5 and 20, right? So those satisfy that. And the A1s and the C1s and the A2s and the C2s, all those counterfactuals are true, right? If the pressure is 9, then the barometer will read 29. Sorry, the pressure is 29, the barometer will read 29. Right? 30, the barometer will read 30. So both of those sets satisfy this relation he's describing. So barometer readings depend counterfactually on barometric pressure, right? And so this is a counterfactual dependence relation. And that counterfactual dependence relation is sufficient for what he calls causal dependence, right? Okay, so far we've defined causal dependence, right, in terms of this counterfactual dependence relation between sets of events. These have been in terms of propositions, right? If A is true, then C is if A is the case, then C is the case, right? But he wants to translate this into events, right? Because he wants to talk about causation among events. That's fine. That's easy enough. So let the proposition O, E in parentheses just be the proposition that event E occurs, right? Now we can define causal dependence between events in terms of the propositions that describe those events, right? So I dropped the cup. That's an event. There's a proposition that says I dropped the cup. So if the truth of those propositions are related in a certain way, then we'll say that the events are also related in the same way. Again, if the propositions are true, right, that's the important thing. The proposition does pick out an event in the world, so as long as the proposition is true, we can connect it with an event. So let C1, C2, and E1, E2 be distinct possible events such that none of the C's and none of the E's are compossible, right? Just like the barometric pressure and the barometer readings, right? And then let's say that the family of E's, right, of events now depends causally on the family C of causes, just in case these sets of propositions depend counterfactually on each other. Okay, now we want to get to single events, right? So we've defined causal dependence in terms of counterfactual dependence, and we've defined it in terms of sets of events, right? So now consider two specific events, E and C. We'll say that E depends causally on C if and only if the family, now this family only contains two propositions, right? The proposition that E occurs and the proposition that E does not occur depends counterfactually on the family C and not C, right? What that means is whether or not E occurs depends on whether or not C occurs. So if C, then E, and if not C, then not E. This is just Hume's definition, right? It said something is a cause if it hadn't happened, then the effect wouldn't have happened, right? And if it does happen, then the effect will happen, right? That's right. What? So this is all the machinery to rigorously restate what Hume had stated in the first place, right? As his second definition of causation, right? But Lewis is a little more careful than Hume. This is actually not a definition of causation itself yet. Instead, it is a definition of causal dependence between individual actual events. So we haven't said yet why. Why is he trying to make this distinction between causal dependence and causation? What's the difference? Causal dependence among actual events, right, entails causation. So if E would not have happened without C, then C is the cause of E. But it's not necessarily true the other way around, right? The converse is not always the case. The difference between causation and causal dependence is causation has to be transitive. Causal dependence, which is defined as counterfactual dependence, remember, is not always transitive. So let's explain that. Here's some counterfactuals. If I hadn't gone to UCSD, I would have gone to UT Austin. Also, if I had been a chimpanzee, I wouldn't have gone to UCSD, right? So should we say that if I had been a chimpanzee, I would have gone to UT Austin, right? Right? If you understood those as strict conditionals, that would seem to follow, right? But these are counterfactuals, and they operate in a different way, and they're certainly not transitive, right? So it's not the case that if I had been a chimpanzee, I would have gone to UT Austin. And that's because counterfactuals are a special sort, right, of conditional statement, and they are not transitive. But causation does need to be transitive, right? If C causes D and D causes E, then we would say C is a cause of E, right? If my striking the match caused the pile of oily rags to burn, and the pile of oily rags caused the house to burn, we would want to say, yeah, my striking the match caused the house to burn, right? So we need something else than just counterfactuals, that transitivity happening. How do we do that? Consider three events, C, D, and E, such that E wouldn't have happened without D, and D wouldn't have happened without C. Certainly in that case, right, this is a causal relation, or certainly C is a cause of E, right, even though strictly speaking, E does not depend counterfactually on E, because remember, it's not transitive. But we can define a transitive version of causal dependence that will be sufficient, right? So let C, D, E, whatever, be some finite sequence of actual particular events that are causally dependent on each other. So D depends on C and E on D and so on, right? Call this sequence a causal chain, right? So one event is a cause of another if there exists a causal chain leading from the first to the second. So in other words, we're using counterfactual dependence between single events to define causal dependence. Then we define a chain of causal dependence among a series of single events to define causation. So we're sort of just stipulating the transitivity, right? We're saying, right, a set of counterfactually dependent, right, events that is also transitive, right, in that it creates a chain, that's going to count as causation. Okay, so that's his account of causation, right? It's just counterfactual dependence, really. He has to do a little work to define it in terms for single events, right? And then he says it's got to be transitive, right? So you got to kind of just stipulate in the transitivity, a causal relation. So there's some big advantages to Lewis's account. Enormousness, right? Remember that was a problem with Mackey, right? The enormousness of causes. I'm sorry, not Mackey, but Mill, right? Mill said the cause is just the whole big set of necessary conditions. Well, Lewis can identify a single event as a cause. Right? If the electrical short hadn't happened, the fire wouldn't have happened. So that's better, right? That accords with our intuitive notions and science tries to investigate causes, right? Um, Now, for Lewis, there's going to be other causes, right? So if there hadn't been oxygen present, then the fire wouldn't have happened too, right? So it seems that that counterfactual is true as well, and so it seems like oxygen is also a cause. But Lewis says, yeah, sure, oxygen is also a cause. Right? He's not saying the cause is the whole set. He's saying there's lots of different causes, right? That's fine, I guess, right? Is it? Do we? Are we okay with that, or is there a problem with it? I'll leave it up to you. Remember, repeatability was a problem for Mackey, right? Right? Because even though Mackey was able to single out a single event as the cause, it was still in the background of this huge set, right, of events. And because it made use of this huge set of events, it was hard to say that that set would ever be repeated, right? So it was hard to say that a cause could ever be repeated, or an event like a causal relation could ever happen again. And we don't have to worry about that because we don't have to use a huge set to get to a single event, right? So problems of effects. So these are some real problems for Lewis that, he offers some solutions, but you may or may not agree with them, right? One is the problem of effects. So say you've got two events, C and E, right? And the relationship is so tight that C never fails to produce an E, right? Well, then we end up with this counterfactual that says if E hadn't occurred, C wouldn't have occurred, right? Because E's never happened without C's or something like that. Right? Well, if that relation is that tight, then and so much that that counterfactual ends up being true, then it ends up that the effect qualifies as the cause of the cause, right? And I don't know, maybe you don't want that, right? Maybe we want to say that cause there's a distinction between causes and effects even in those situations, right? There's also the problem of epiphenomena, right? So if C is the cause of F, but is also the cause of E, which is unrelated to F, but always occurs when F occurs, then it would be true, the counterfactual would be true that if E hadn't occurred, F wouldn't have occurred either. And then now we've got something else causing F besides the real cause, C. So, like, for example, an electrical short will also cause a flash of light, right? And it also causes the fire. You don't want to say that the light caused the fire, right? It was the short that caused the fire. But since the light is always there every time the short is there, it's hard to pry those apart counterfactually, right? And you end up maybe having to say that the light caused the fire. So Lewis has some solutions to these, right? So first of all, he doesn't want to just stipulate these problems away. He thinks they're real problems that have to be dealt with, right? So like you could get away, the problem of effects wouldn't be a problem if you just stipulated that causes always happen before their effects. But he wants to leave it open that backwards causation is possible, right? That's really an empirical question. Philosophers shouldn't be ruling that out a priori. And anyways, it doesn't solve the problem of epiphenomenal causes, right? So instead, he says he wants to deny the counterfactuals that supposedly cause the trouble. So we should say that even if E's always follow C's, we should deny the claim that if E hadn't occurred, C wouldn't have occurred. Instead, we should say that C would have happened without E. So suppose that drops in barometric pressure, right, are always covary with drops in the barometer reading. Well, we don't want to say that the barometer reading causes the drop in barometric pressure. So we want to deny the counterfactual that says if the barometer reading had been lower, then the pressure would have been lower. And we want to say, no, something else would have happened, right? The barometer would have broken, right? Or the barometer would have malfunctioned, but we would just want to deny that counterfactual, right? And he's going to use the same approach for the problem of epiphenomena, and it gets even a little more implausible, right? But he says, cost-benefit analysis, this is just the better way to go, and he's going to bite the bullet on this. So, right, electrical short always causes a flash of light, right? So they always two go together. So anytime a short causes a fire, there's also a flash of light, right? But we don't want to say the light flash caused the fire. So instead, Lewis is going to insist that, yeah, if there hadn't been a flash of light, the fire still would have happened. There would have been a short without a flash of light. Now, you might need to break a law of nature to make that true, right? Because electrical shorts create light. That sort of always happens. But he says it's worth breaking a law of nature in the counterfactual world, right? To having this problem of epiphenomena. So that's one thing about Lewis. He's willing to bite bullets and accept very weird things if it makes the theory coherent, right? As we'll see next week when we talk about modal realism. Okay, so he says, hey, we can accept small miracles in counterfactual worlds if it makes our theory make sense, right? And it makes it the case that the flash didn't cause the fire, right? It's up to you, right? You might want to say, you could take the opposite stance and say that since electrical shorts are always accompanied by flashes of light, then the short couldn't have happened without the flash, and thus the flash. If you sort of insist on that, then there really is no way to rule out the flash of light as a cause. But Lewis thinks that it's worth giving up on that intuition for a better account of causation. So something to think about. Maybe, I don't know, if any of you are still thinking about changing your paper or have read ahead, you could write on that. There's a lot of some loose ends here in Lewis's account, I think. And next week we will talk about Lewis's account of realism and some other sort of modal realism, possible worlds, and some other